Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host as usual is Tobias Macey, and today I'm welcoming back Russell Keith-Magee to talk about the latest status of the Beeware project, the state of Python's black swans and how the hunting is going, and a little bit about how the PyScript project ties into his ambitions for world domination. So Russell, welcome back. For anyone who isn't familiar with you and hasn't listened to the past episodes, if you want to just give a brief introduction.
Hi, so my name is Russell Keith-Magee. Thanks for having me once again. I am a long-term fixture in the Python community. I joined the Django project as a core team member in early 2006, and I've kind of just rolled on from there. I'm a regular fixture at conferences, and after many years of working on Django, I've sort of moved on to my own project, which is the Beeware project, looking at Python on mobile, making Python a viable language for GUI development on all the platforms, all the desktop platforms where you have been able to, but it hasn't been very popular as a GUI language, but also on the new platforms, iPhones, Androids, things like that, where Python basically doesn't have a story at the moment, doesn't have a good story at the moment.
For folks who haven't heard the story in the past couple of episodes, which for reference were in 2019 and 2016 respectively, do you remember how you first got introduced to Python?
I do. It's to the extent that my memory is fading with time. First time using Python would have been at about the Python 1.5 days. Back then, it was mostly a system administration language that was used to tie together installs. Basically, it was a tinkering language for just tying together little bits and pieces. Got a little bit more serious in the early 2000s and around the 2.0-ish, 2.1-ish timeframe, mostly just tinkering on my own little projects. And I sort of found it to be an elegant little language that fit in my head to get things done and prototype interesting ideas. I had a bunch of little projects I was toying around with at the time. Python was a language that let me prototype those quickly. At some point, I had the grand realization that the web was an interesting thing that might help me with some of these projects. And so I should probably work out how the web worked, because despite having a PhD in computer science, my PhD was entirely theoretical. I didn't know how to do things with computers. I just knew how to, theorize about them. So I started looking into web programming, tried a bunch of web frameworks. None of them really stuck, and just happened to stumble across Django just after it had been open sourced. And for whatever reason, it just stuck. It had really good documentation. I could follow through the tutorials, see where it was going from there. And because it was Python and it was a language that I knew, when I didn't understand what the documentation was saying, I could dig into the source code and work out what was actually happening. And for the first time, the web made sense to me. Within about 2 months of downloading Django, I was a member of the core team, at least partially because at that point, there was so much low-hanging fruit that any contribution was a valuable contribution, and it just all rolled from there. I was able to pivot what was my spare time open source project into something I was actually using in a day-to-day job, and that sort of encouraged me to keep working on it and keep developing with it until it became sort of the behemoth that it became within a couple of years.
The main focus for the conversation today I want to have is kind of catching up on where Beeware is, capitalizing on your recent news about the fact that you are now working on it full-time, and checking back in about the kind of current state of what you see as the potential black swan events for the Python language and community. For anybody who isn't familiar with the Beeware project and your overall vision there, I'm wondering if you can just give the elevator pitch of what it is and why it matters.
So the idea behind the Beeware project, there's a couple of different elevator pitches you can give depending on who you're talking to. One is to say it's Django, but for application development. So Django is a framework for perfectionists with deadlines. It lets people crank out a website very, very rapidly. The web is still good, the web is still useful, the web is still being used everywhere, but there are occasions when a website just doesn't cut it and you need a mobile app. And Beeware is there to try and fill that gap, to make it as easy to develop a mobile application as it is for you to build a website with Django. So the intention is very much there to say, okay, just using Python, develop an application that is indistinguishable from an app that had been developed using native Android APIs, native iOS APIs, without having to learn all the eccentricities of those ecosystems, to provide a framework that lets you use Python to develop those apps. That actually at least partially comes out of my own experience back in the day when I was running my own startup. We had a very, very successful Django website that everybody loved and was incredibly productive. And I was a one-person engineering team who was keeping that entire product going. But we needed a mobile app because we needed GPS tracking and we needed to be able to take photos and all this kind of thing, which you just can't really do with a mobile web app. And so we ended up using Cordova at the time because we needed to have something that was on both iOS and Android. And I hated every minute of it because it just always felt like I was fighting it every step of the way. And I couldn't reuse, I had this entire code base in Python of business logic, and the guts of the application was going to be on the same as it was on the web as it was on mobile, but I couldn't reuse any of that. So that kind of got me thinking, why can't I do this in Python? And many, many years later, I'm now at the point where we can say, well, yeah, you absolutely can. It's just a matter of dotting the I's and crossing the T's and putting the foundation in place so that Python can run at all. And once Python's there, then you can talk about the apps you're going to build.
The other piece of it is the keynote that you gave at PyCon US 2019 talking about the potential black swan events for Python, one of which is this lack of support for mobile application development and the fact that a majority of young people who get introduced to computing do so through phones and tablets, and they want to be able to build for the platforms that they and their friends are using, as well as some of the other sort of major potential risks to Python, like the fact that while it is useful to power applications on the web from the back end, there's still no real good answer for being able to do that from the front end and be able to actually have a full stack Python application in the same way that you can do with JavaScript. And then also the deployability challenges that are being eaten up by projects such as the Golang ecosystem, where you can very easily get a single binary that you can deploy as your entire application. And I know that there have been movements in all of those areas, and I'm just wondering if you can maybe reprise your thoughts on the black swan potentialities for Python, and maybe reflect on the past 3 years of hindsight from since you gave that presentation.
Sure, yeah. So the idea behind a black swan event, it comes from papers written by Nicholas Taleb, talking about things that can happen in an ecosystem that absolutely shatter the ecosystem, could radically change the way you see the world, the way people perceive the world, that in retrospect are completely obvious. But at the time, no one could see them coming. It comes from the idea of talking about black swans, where in the 1700s and in the good old days, everyone in Europe knew that all swans were white. And then someone got on a boat and dropped in on Western Australia, my hometown, and discovered that, no, there are black swans as well. Now, the black swans had always been there. And if you think about it, a swan is just a bird. There's no reason it can't be a black bird as well as being a white bird. But it hadn't occurred to anybody that swans could be black at all until someone turned up, saw the black swan sitting there and said, oh, yeah, okay, that's a black swan. In the case of things like technology, it's these things that happen, these events that occur that in retrospect were completely inevitable, but no one saw them coming in the first place. The microprocessor, microcomputer revolution was kind of one of those. In the good old days, computers were mainframes. Computers were huge devices. You bought one great big one for your machine, for your company or whatever, your Fortune 500 company, and everyone had a dumb terminal that was attached to it, and you programmed away. And then some people built the Apple II and the Altair and personal computers of that kind of nature. Looking at it now, why on earth the people who were selling mainframes, why did IBM not think that these microcomputers were going to be a big thing? Because I can take this computer and I can just manage it myself, and I can move it around, and I can, you can buy lots of small units instead of having to buy one massive unit. So in retrospect, it's a black swan event. It's no one at the time. Popular wisdom was that computers had to be large. Something happened, the technology changed slightly, all of a sudden these microcomputers became plausible, and then they took over the entire world. The keynote that I gave at PyCon, 3 years ago, was essentially saying, okay, so what's that for Python? What's going to happen to Python to make Python irrelevant? Python today is, by any measure, one of the top 3 programming languages in the world, most popular, most useful, most used, however you want to take those measures. What's going to change that? Why is that not going to be true in 10 years' time? And given that we can do that preemptively, we can talk about those sort of things preemptively, how do we avoid those catastrophic events, end up killing Python or moving it to being some sort of niche language that's only ever used in a legacy sort of capacity? A couple of the ones that you sort of mentioned already, but that I pointed out during that talk are things like packaging. The idea today of how do I give my Python code to someone else is a non-trivial task. The fact that Python doesn't run on, doesn't with an asterisk, but primarily is not distributed on iOS devices, on Android devices, is a big problem because they're the computers people have now. Like the example I give is that when my son started high school a couple of years ago, he didn't have a laptop for school. He had an iPad, and he knows Dad's a programmer. Maybe can I learn to program, Dad? What do you mean I can't learn to program the same language that you program because you can do Python on your computer? Why can't I do Python on my iPad? That is played out in the long term. That's an existential threat for Python. And so a lot of what Beeware is kind of doing in some regards is trying to address those issues, trying to make sure that Python does have a good packaging story, that Python can run on iOS and Android, that Python is a viable language for developing iOS and Android apps. Those are obviously big projects, and sometimes it feels like you're completely swimming upstream because you're fighting against Apple wants you to write in Swift, Android wants you to write in Kotlin, and packaging is just an eternal nightmare of just trying to get things consistent because no two computers are ever the same. But these are problems that need to be solved. And like you said, when a language like Go does have a good solution, it is an absolute stimulus for the growth of that language. So if we can crack that nut, if we can get a good packaging story for Python, then it becomes a case where you just don't care that the app's written in Python because you can give it to somebody else and they can just use it. We're not there yet. I'd like to think we can get there, and Briefcase is sort of proving that it can be done. We've just got to dot the I's and cross the T's, I guess.
There are, as I said, a number of evolutions in the Python community and in some of the surrounding technologies that serve to either exacerbate or ameliorate some of these problems. So in the packaging space, as you mentioned, there's Briefcase, there's the PyOxidizer project that's aiming to be a solution for some cases. There is the PEX and the Shiv formats that make it easier to get your Python application into a Python runtime, but not necessarily hand it off to an end user. From the kind of web perspective, WebAssembly has come along to offer some potential promise to being a solution to any language running in the browser, not just JavaScript. And from the mobile app development perspective, I know that you've been pushing on that very heavily with Beeware. There are some other projects, most notably Kivy, that are pushing at other aspects of that mobile platform development. And I'm wondering, what are some of the most promising avenues that you're exploring to be able to address sort of the key areas that you're focused on?
So I'd say there's probably 2, and you've sort of hit on both of them in what you've said there. The first is WASM. Like WASM, WebAssembly, is a big deal on a level that I think a lot of people don't really appreciate how big a deal it can be. Go back at PyCon, it was 7 or 8 years, I think, ago at this point. Gary Bernhardt gave a mostly tongue-in-cheek talk about the future of JavaScript, and that was a very deliberate mispronunciation, talking about JavaScript as a runtime, not as a language, but as a runtime. And that's essentially what WebAssembly has essentially got us. The thing that I find eternally ironic about WebAssembly is that JavaScript got the name JavaScript because it had to have the name Java in it, because Java was huge in the mid-90s, and it was because it was write once, run anywhere. Java tried to be write once, run everywhere by convincing everybody that everyone was going to rewrite all of their existing code in Java. And that just was a dumb idea from the outset. Like, they've done good things, and Java is a good programming language, but you're not going to convince everyone to convert all of their existing code to a completely different programming language just so they can run it anywhere. JavaScript did a similar kind of thing, picked up the name Java because it needed to be run everywhere, has no other relationship with JavaScript other than that capability, but did manage to get to run everywhere because it was in the browser. And because the browser became so important, JavaScript got to be so optimized. WebAssembly is just sort of taking the core internal jittered runtime of JavaScript and making it run really, really fast and giving other programming languages access to that jittered runtime. So in a really weird way, JavaScript is going to deliver the promise that Java originally had, but by completely ignoring JavaScript, the language. The WebAssembly part is the part that's interesting. JavaScript as a runtime that you can compile to. Because once it's compiled to as a runtime, you essentially are now down to a linking problem with a common linking format that any language can use and be interoperable. It's in some regards a bit like what the C API is for static languages. You can say this library, this Fortran library is compiled to the C API, and this Pascal library is compiled, and this, pick other random language library is compiled. They can all talk to each other because they're all using the C linking API. The complication is that the C API is different, or the C libraries are different on every operating system, and so they're not interchangeable. But WebAssembly, they are interchangeable because it's all JavaScript under the hood. So all the languages can intersect at this same common intersection point of WebAssembly. And that's a hugely powerful thing to have, because it means that every language has a common exchange point. Every language can start to interchange, and the thing that they're interchanging with works on every platform and has been massively optimized to work on every platform.
The other interesting piece of it, too, is that now WebAssembly is being pushed as a solution to problems outside of the browser as well, with server-side WebAssembly runtimes.
Indeed, yeah, exactly. And the extent to which that is a good idea, I'm willing to at least, there's sort of a, how many levels of abstraction do you want to have layered on top of each other before it's, we build incredibly faster and faster chips, and then we go and spend all of that time working in abstraction layers. Yes, it does make the development process easier. There's definitely a trade-off there that I'm not 100% sold on, but it certainly, it does, can't argue that it works.
Yep. And continuing on the trend of WebAssembly, there was a recent announcement of the PyScript project that came out of Anaconda, which is building on top of that WebAssembly capability to put Python into the browser, layered on top of the Pyodide project. I know that you are at least tangentially involved in the PyScript project. So I'm wondering if you can just talk to some of the ways that scope of work fits into this Venn diagram of the objectives that you have for Beeware of being able to run Python everywhere and build GUI apps that can, be packaged up and not have to worry about, I'm running Django and Python on the server and JavaScript in the client. And then also the overlap with these, portents of black swan events.
So PyScript is it's a really interesting beast. So when it was announced, Thea Flowers popped up and sort of made a comment to the effect, the exact phrasing I'll forget, but it's something like, the best way to install Python is just not to install it at all, which is essentially what PyScript is giving you. It is using this platform that everybody has. Everybody has a web browser. Everybody can get stuff by script linking in documents from elsewhere. And you can now do that with Python as well. You can now just drop into a block of code on a page, dynamically modify the page that you're sitting on in Python, and it brings Python to being at the same sort of level that JavaScript is, as a language that is just everywhere. On top of that, as with all things, there are layers that are going on here. There is just getting Python to run in the browser at all. And that's something that's a capability that actually will be in Python 3.11 natively. Like WASM targeting is something that's actually out there as an officially supported platform. Pyodide is a number of things. One, it's a bunch of libraries like all the math processing libraries and NumPy and SciPy and that kind of thing compiled up so they're accessible. But it's also a bunch of tooling like micropip, which essentially lets you do import requests, but requests is coming from http://pythonrequests.org. So you don't have to worry about how do you include it into the page. You just hyperlink into the fact that you want to use that thing. PyScript then puts the layer on top of that to say, okay, well, let's make it really easy to describe what environment we want my page to have and just drop Python straight into a PyScript block. And then do this sort of negotiation with interacting with the DOM and what else have you. But full two-way interoperability. So your Python code can talk to the DOM and the DOM can talk to your Python code, building up an application in the web browser entirely client-side. So you don't need the server-side anymore. You just need to deliver the shell in which you're going to build things. And you've got a fully functioning programming environment, has all the features that you needed to have. That's an incredibly powerful tool in terms of getting people who aren't sophisticated computer operatives working out that they can actually build things. Like building their Hello World application doesn't need them to learn what a virtual environment is and to learn about file systems and learn about how to set your current working directory and why your Python path isn't working and why you need to preface running Python with Python pi-m or else the thing won't run. All of those problems go away because the code is just there and it just runs and it's already set up for you as long as you configure to say, these are the things that I need for it to run. What then gets interesting is sort of the transition point between how do you take what PyScript is doing in the browser and progress it even further, which is kind of the bit where I get really interested. Because one of the first things that came out of PyScript is someone saying, well, okay, can we just wrap this up as Electron? And my comment is, well, why on earth are we doing it in Electron? Why don't we do it in Python? Why don't we do it with Toga? Why don't we do it? I've written up a little shell thing called Positron, which is, Python electrons, which is essentially a Python app that can be distributed using all the Beeware tools, using Briefcase, using Toga, that is just a native window that has a browser in it, into which you put your PyScript code, and it runs. Like, it's the same app, except that it looks like an app on your desktop, and it's distributed as a disk image or a DMG or an MSI or whatever. But then you can take that a step further. Okay, let's make it a hybrid. Rather than having just a window that is just a web browser that's running PyScript, let's make that window just one of the widgets. Have some native widgets on the side, select buttons or some other functions that you want to build up. But when I want to do this complicated piece of logic or this thing that I want to build dynamically, that's the PyScript widget. Or when I want my visualization, I can just drop the visualization in and have it interact with my native code or interact with my PyScript code. Sort of there's a transition here from the skills that someone learns in their high school programming class, and bit by bit they become, I don't want to say more serious, but more and more like a native developer as time goes by. And eventually, maybe they do completely leave the Python ecosystem and discover that this thing that I've been doing in Python would actually be better done in Kotlin or be better done in Swift. But we can transition them through a lot more Python before they get to that point. And there's a lot of capabilities of things that become possible because you can build them entirely in Python to smooth out that first, year, 2 years of development. And for a lot of people, that's all the programming they will ever need to do. It is literally just the gaffer tape of keeping their lives together. They don't want to have to do a 3-year degree or even a 12-week bootcamp course to be able to control their devices. They just want to be able to get stuff done. And all of the stuff around the outside of ecosystems, like the JavaScript, the whole ecosystem with Webpack and Rollup and resource compilation, and that is just like, I've got a PhD in computer science and I don't want to have anything to do with that stuff. Why on earth would a high school student want to have anything to do with it? So what I see PyScript as is this sort of massive enabling tool that gives people the ability to have functional programming environments that can then, with the use of things like Beeware and sort of the capabilities that Beeware have, gives them this transition into much more capable tools over time when and if that is needed.
And just to play devil's advocate for a moment, we've had ways of being able to run Python in the browser for a while. We've got Python Anywhere, we've got Replit, we've got Transcript, we've got Brython. So why is PyScript so innovative and new?
Depends on which one you're looking at. Things like, there are solutions that are essentially server-side. So things like, I will stand corrected on this one, I think Replit is server-side. You write code, it gets sent to the server, and the response comes back to you. That's fine, and it can work, but I'm telling you as someone living in Australia that you cannot break the laws of physics. If a server is on US East 1, it is literally on the other side of the planet to me, and you can see the electrons move there because there is a round-trip time. You literally cannot fix that. So it works, it can work, but it's not quite the same. You go to something like Transcript, that's a transpilation that takes code that looks like Python and tries to turn it into the equivalent JavaScript. That can work, asterisk, because you end up hitting across all the places where Python, the language, and JavaScript, the language, have different semantics, and you end up having hideously Baroque JavaScript code to accomplish the same syntactic functions as what Python is doing, the same syntactic conventions as what Python is doing. Similarly, with things like Python, you've then got a re-implementation of Python in the browser. And it's like there's a whole duplication of effort there. The biggest thing about WebAssembly is that it is just C. It is the same C Python you are running on the desktop. There is no additional recompilation needed. All of the C modules continue to work exactly the same way. If those C modules link in something else, you can pull in those, as long as you can compile those additional C libraries as WebAssembly. And if they're written in C, they basically can be. You can get the entire stack with essentially nothing more than a set of compiler flag changes. You don't have to go and reinvent the wheel, redevelop a compiler, redevelop a parser, redevelop a standard library to get to something that's functioning in the browser. It is genuinely using the browser as an execution environment.
And the other challenge that always comes up with things like, in particular, Python, I know, was that you end up with this massive download that you need to run, client side to be able to even load all the functionality to be able to write the Python. And I'm curious how that problem is being addressed or thought about when we're talking about things like Pyodide and PyScript.
It is still an issue, and it is still there. As it currently stands, the PyScript WASM payload, when it's delivered, memory serves as about 3.5 megabyte. I could be a little bit off on that one, but we are talking megabytes anyway. That is still an issue. It is still there. That said, it needs to be downloaded once and it can be cached. And looking longer term, there are ways that it can be trimmed down. One of the Beeware projects that's now slightly on ice was a Python browser called Batavia. And essentially one of the reasons it was small is that what it threw overboard. One of the things it threw overboard was the parser and the compiler. Essentially, it only shifts the bytecode to the browser. That is actually a possibility wouldn't be inside PyScript, because PyScript does rely upon the scripting language actually being there. But like in terms of using Python on the client, that is a stripped down thing that could be done. The other thing is that you can do a lot more dynamically. Like you can look at dynamic loading of parts of the compiler or parts of the language. For example, Python has a fully fledged complex number data type. I have never used it in my life. I know that it's there because I've re-implemented Python and I need to have control for this data type that existed. If you can structure your WebAssembly well, you can essentially deliver the core bit of the kernel of the Python that you need, and then just pull down the other WebAssembly bits when you need them. Essentially just have them as loaded when you invoke them, and you only load at the beginning the things that you know you're going to need. There's a lot that is way off in terms of the capabilities, but the sort of thing that becomes possible because the web has baked into it as a platform dynamically accessing resources from somewhere else as part of its platform definition.
Yeah, this also brings in a little bit of Brett Cannon's sort of spiritual journey that he's going through of what really is Python? Like, what is what is the spirit of Python that we actually need to be able to say, this is Python versus, Python is only the CPython runtime?
Yeah, no, absolutely. And it is the big question. It's one that I have asked many, many times in the process of packaging apps. Is the ability to compile Python code a necessary part of a distribution of Python? In all of the apps if you're distributing an app in the iOS App Store, no, it's not, because you're not going to be dynamically generating code. It is a language interchange and it's the bytecode format that's interesting. Does it need to have an implementation of OSS audio? That's a required part of the standard library. Not many people use it. It's actually, it's a dead battery that's getting pulled out in 3.13, but it's there in the standard library. You've got to deliver it. Can you strip that out? What other modules can you strip out? If you never invoke the bzip library, does that need to be there? Can you leave that out? Can you strip down to a minimum viable Python? That is the 2 or 3 modules that you absolutely have to have for the interpreter to even start, like, sys and things like that, and then just leave everything else up to the user to pip install. There are a multitude of issues that are tied up in that, but it's a question we've got to ask, because the more we can strip down that binary, the smaller iOS apps get, the smaller WebAssembly apps get. There are a lot of optimizations that can be had out of doing that kind of tree shaking in the long term.
Circling back around now to what I had said earlier when I introduced the topics for this conversation, is that you are now actually spending your full-time job working on Beeware, which is a drastic shift from where you had been the first time we spoke about it and many other times since then, both on the podcast and in person. So I'm wondering if you can sort of relate whatever bits you find interesting or worth sharing to people who want to know sort of how that came about and what that sort of current situation looks like and means for the future of Beeware and the potential impacts of that added investment to the broader Python ecosystem.
I gave the keynote in 2019 at PyCon talking about these Black Swan events and had met at that point a couple of times, I think, but I had caught up with Peter Wang, CEO at Anaconda. And, just kind of, it was a good conversation, didn't really go anywhere in particular. Late last year, and Anaconda was on a bit of a growth kick. They're hiring pretty aggressively at the moment. If you are looking for a job, we are desperately looking for Python people. A conversation started up again about Beeware and what could be done if Beeware had more resources. And without wanting to be too much of a corporate shill here, but like Anaconda's core business is selling enterprise solutions, selling services that are useful to the big end of town. And it's in their interests for the ecosystem that they have spent a lot of time and resources building a company around to continue to thrive. And so they are strategically looking at, well, okay, what's going to cause our ecosystem to collapse? What's going to cause our market to shrink? And further than that, is there anything we can do to make our market grow? And so that's essentially the reason why they've ended up hiring me, is that they can see value in having Python available as a viable solution in iOS and Android. Not because they want to particularly monetize Beeware or anything like that, but because all of their enterprise clients are doing all of the numerical processing and all the big data stuff that they're currently doing in Python. But they're also doing iOS development. They're also doing Android development. They're also doing web development. That's a bigger market for them. And so Anaconda has for a long time given a lot of stuff back to the open source community. This is them just saying, okay, this is part of the Python ecosystem that is currently underserviced in terms of the amount of resources that are going at it. Let's throw some resources at it and see what we can make happen. And yes, as of end of March, I joined Anaconda to work on Beeware full time. I'm essentially at my own recognizance, not completely left loose, but I've been given the directive to go do the Beeware things and show us what we can do. And we are in the process of trying to hire, at least one in the short term and probably at least another one by the end of the year off-site to work with me to make that happen. And literally, the big change is that I have the spare time to do it. I have been tinkering with Beeware in mostly my spare time for 7 years, 8 years at this point. I've sort of lost track. There are times where I have lots of spare time. There are times where I have no spare time. Moved house at the end of 2020, and for the 6 months before that and 6 months after that, everything was house. There was no, I could stay on top of mailing lists, and that was basically about it. I now have, 9 to 5, Monday to Friday, to just work on Beeware. And so all these little things that have been lingering, I can actually pay attention to. I have spent the last 2 weeks trying to get the Beeware story straight on Apple's M1 hardware. M1 didn't exist 2 years ago. It is now most Apple laptops. They are still trying to get their story straight in terms of how you compile things, and Beeware had kind of lagged behind. We did get a little bit of support last year to sort of do an initial port, but there was still a lot of pieces missing. I've now got the time to sit down, actually do the job properly, get everything in line and get it all sorted out. And that's the sort of thing that doesn't happen unless people actively fund open source projects like Anaconda does. And to be clear, Beeware is not the only project that open source project Anaconda supports. They've got a whole open source team or open source group that I'm a part of. And so the big change is that we now have the resources to do the housekeeping that needs to get done and do the forward-looking and actually make plans to say, okay, in 6 months, this is what we're going to have available, or this is what we aspire to have available, as well as dealing with all the other emergencies that pop up because Apple decides to launch a new hardware platform or whatever else they decide to do that turns out to be interesting.
But now what are you going to do with all your newly empty spare time? Are you just going to wander around the house aimlessly?
The irony is that I'm not going to have any more spare time because it's still, I work on open source because I enjoy it. And it's like, it is kind of how I wind down, and the community aspect of it. I am now able to spend a lot more time, work hours, focusing on engineering, which you need, just 8 hours straight looking at the problem. But the other stuff, like dealing with community and the social is the wrong way of putting it, but sort of the human part around the outside of the project, that's the part that I find personally invigorating, because you hear the stories of people using the stuff that you're working on. So I imagine I will still be doing a lot of that on my weekend. But I can also do some of my hobbies can start to come out of the closet again, I guess.
Absolutely. And so with the newfound support and the fact that you do have the freedom and the motivation to start building out a roadmap and thinking more long-term with the confidence that you will actually be able to start delivering on those ideas, what are some of the potential roadmap that you're considering, or areas that you're interested in exploring, or particular types of contributions or skill sets that you're looking to become engaged with Beeware?
The short term is fixing or addressing the technical issues that have been lurking that we know need to be solved to make this real. The sort of most pressing one right at the moment is M1 hardware. It really did throw a spanner in everything, because everything has had to change to support the fact that your laptop and your phone now have the same CPU architecture. The next one after that is essentially looking at binary packaging or binary modules on mobile. So the one that, I want to install SciPy on my phone. It's a use case people want. And it's obvious why they want it, but it's not a trivial thing to solve. So we've got to work out how to make that happen. I've got some ideas about how it can happen, fairly sure it can happen, like technically can happen. And a couple of things have changed, and particularly in the iOS ecosystem, to make it possible over the last couple of years. One of the big things that's going to happen over the next couple of months, or we're hoping will happen over the next couple of months, we'll start to see a much better story for packaging of third-party binary modules, not just pure Python modules. And this is actually an interesting case where the intersection with Anaconda is actually a real synergy there, because Conda's main value offering, of their main value proposition as a binary management platform, so that you can just install SciPy without having to work out how to compile the Python compiler or how to compile the Fortran compiler that you need to make SciPy work. That's a macrocosm of the problems that mobile development has generally. You have a known hardware platform, a known API that you can work against, a known set of tools that are available on the platform, but you've just got to get everything compiled. Once it's compiled, I can give you a binary for iOS and it will work on any iOS device. Likewise for any Android device. So there's a lot of overlap there, and I wouldn't be surprised if there is some changes mean that the Beeware ecosystem leans a lot heavier on, or at least has an option leaning on, the Conda ecosystem for packaging in some places. Beyond that, I think the biggest goal is kind of a 1.0 for Toga, effectively. The mental picture that I've got is kind of the TK inter that is already in standard Python, but not TK please, but with also some nice toys like a HTML widget and a GPS widget and a map widget, the kind of the things that are just table stakes for a mobile phone application, having APIs for those so that you can just do them. Looking longer term, the eternal make it faster, make it optimized, make it smaller, make it more streamlined, make it more bulletproof, all that kind of thing. There is a bottomless stream of more widgets that you can build, especially in the visualization space. Like there are so many panel widgets and visualization widgets and charting widgets and whatnot that would be great to have just drop-in versions of. Things like GUI builders, like being able to lay out the widget, lay out the design of your app without ever having to go to code to do the visual side of things. And the web backend, which has kind of got a little bit of a kick up again because of the PyScript work. And the PyScript effectively has made a lot of what we were trying to do with the web backend a lot more plausible, because it is just, well, I want a PyScript environment that has the Toga package as a dependency, because you can just hyperlink import the wheel of Toga and it's there and it runs. So getting that fully up to a Toga as a web platform built on or adjacent to PyScript is likely on the roadmap as well.
As we have kind of touched on briefly throughout this conversation and more explicitly in other formats, the Beeware project is not one monolithic piece of source code. It is actually a federation of multiple independent projects, and some of which are seeing more activity, some of which have different areas of focus. And I'm wondering if you can talk through some of the efforts that fall under that umbrella of Beeware that have either proven to be dead ends in their own right or have been obviated by other advancements or evolutions in the ecosystem and the technology landscape.
The two biggest ones are the tools that I used to get Python working on Android originally and Python working in the browser, so which are Voc and Batavia. Batavia was a implementation of the Python bytecode machine written in JavaScript, which meant that you could compile your PyC file on the server, ship the PyC file to the browser, and just run it in the browser. Now, that turned out to be a bit of a nightmare to manage, mostly for JavaScript reasons rather than anything else. Because I was one person working in spare time, I had to pick something to focus on, and I decided to focus on mobile rather than browser because there was just so much that needed to be done to make that viable. Voc is a similar story. Voc was a compiler that took Python source code and compiled it to Java bytecode, which was at least one of the ways in to getting Python running on Android devices, because the Android ecosystem is essentially all Java-based, or some asterisk, not quite Java, but good enough for first approximation. The Voc compiler could take any Python code and turn it into functioning JavaScript bytecode, which meant it was then byte compatible with the entire Android ecosystem in the same way that compiling to WASM means it's compatible with the entire JavaScript ecosystem. The biggest impediment to both of those approaches was that in the process of having to re-implement Python, you needed to also re-implement the standard library and anything that wasn't written in Python. So any C libraries, like NumPy, you would have essentially had to re-implement NumPy in Java or re-implement NumPy in JavaScript to be able to use it inside those projects. Batavia is most likely a dead end in terms of the way that it was going. I think WASM will definitely eat its lunch. I think there are things that Batavia did that PyScript or Pyodide or Python in as a WASM target, one of those could possibly pick up, which we mentioned earlier about what is the minimum viable Python? How much can you strip out of a Python interpreter and still have it be Python? Batavia did not have the ability to parse or compile code, but it could run code. And as a result, that was one of the reasons why it was so much smaller. I think that is a facility that is worth investigating. And at some point, I may end up going back to see, can I make a Python interpreter that just runs the Python, doesn't compile and interpret it? Because that is something that would be useful on any deployment target where you're not expecting someone to be running dynamically user-provided code. The Voc story is a little bit more complicated. That one, originally, the very, very first attempt at getting Python running on Android was to compile CPython as an embedded library and embed it into an app. And that worked, but it was really, really slow at the time. This is like 2015 kind of era. It worked, but there were some restrictions about the way that the Android ecosystem interacted with C over JNI, which is the Java native interface. In the intermediate years, those restrictions got lifted, and so it became more viable again. And so what Beeware currently does on Android is going back to that approach. Essentially, we've got some funding from the PSF to get the briefcase story packaging Android working using a CPython as a baseline. That said, if there was an enterprising PhD student who wanted to have a play around, I think there is something still there. Like there are ways of getting around the needing to re-implement all of the standard library by mocking or providing an API-compatible version of the C API. It's just a lot of work. And at least for the short term, there's a lot more that can be done by just using CPython as an embedded library. But given an infinite amount of spare time and another opportunity to go back to university and do a PhD, I think that would be a fun one to play around with.
In the time that you've been building and investing in the Beeware suite of projects, and now that you are able to dedicate more of your time and focus to that, what are some of the most interesting or innovative or unexpected ways that you've seen that tool chain used?
The tools are sufficiently young. It's very hard to point at killer apps that people have built with them. The one that I can point at, or two that I can point at, that I know are out there and are being used that are interesting. One is, they've actually, both of the people who have contributed these apps have become members of the Python core, members of the Beeware core team as a result. One is Maestral, which is an open source Dropbox client written 100% in Python that uses less resources than the official Dropbox client. The thing that's really ironic about that is that the Dropbox client used to be written in Python and they re-implemented it as an Electron app to make it faster and save resources. What Sam Schott's been able to do is implement a Dropbox client in Python, but by putting a tight user interface on top of it, like a Toga native interface on top of it, has been able to build a lighter weight Dropbox client than Dropbox has been able to build on its own as an open source thing. The other is a project called Eddington, which is using in an educational context in a university in Tel Aviv, I think, used for data visualization in physics experiments, physics lab experiments. But outside of sort of the killer apps, the ones you can point out and say, hey, that's in an app store, that's a fun app you can go download and use, the ones that sort of give me the best little warm feelings are the sort of stories that I hear from users who, even though the tools are young, they've been able to use them to do something they couldn't do before. I think probably the best one I've started this year, father jumped online to share the story. His son, who is legally blind, who is 12 years old, had built his first mobile app using the Beeware suite. And you can't buy that kind of warm, fuzzy feeling. The fact that someone who not only is a kid and has built his first mobile app, but has done it with visual impairment as an added degree of difficulty in getting through it, but also that it's a validation of one of the reasons why Toga does things the way it does. Like, Toga is a native widget toolkit. It doesn't reinvent the wheel, doesn't build its own widgets. It uses system native widgets. And one of the side effects of that is you inherit all of the accessibility controls that the operating system provides. And because we've taken that approach, this app, this visually impaired kid was able to build, was accessible because it was using all of the native APIs that were supposed to be there. So, both in terms of validation that, yes, I'm on the right track by doing the right thing and using the native APIs, but also that, even though it is still a very young tool, it is being able to be used to get people into programming, to make them realize that they can build things with computers. And ultimately, that's the thing that keeps me going, hearing stories like that.
In terms of your own adventure and experience and sort of career path that you've been on since starting the Beeware suite, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I guess it's never underestimating how much a hostile platform can make your life difficult. iOS and Android both. Neither of them are free of sin in this particular case. They are a constant source of frustration because we are not doing things the way they would like you to be doing things. And the transition to M1 hardware, Apple has got Xcode and they've got instructions of what they'd like you to be doing. But if you want to not use Xcode and not use the libraries or use the Swift as the sort of blessed language, you are so on your own, it's not funny. Like, it's possible and it can be done, but it's not something anyone is doing accidentally. Likewise, Android's build tooling, I swear, if I ever meet some of those developers in a dark alley, it's not going to be a fun conversation because why they do some of the things they do, how it does them, the way they report errors, the way things come out are just beggars belief sometimes. And it shouldn't be this hard. It really shouldn't. If I am able to stop anyone else from having to go through this pain, then I'm going to consider that time well spent. Because one of the reasons Python is a successful language is because people have been able to get things done with it. Even then, Python has a lot of problems. And there is still a lot of work that needs to be done to make Python even more accessible to everybody. But my God, Python has got it over other languages in spades a lot of the time. The amount of messing around that you need to do to get stuff working on iOS and Android is just phenomenal. So
For people who are considering investing their time in learning and using one or many of the tools in the Beeware suite to address some of these challenges of being able to build for mobile platforms or build for the web and stay in their comfortable, cozy space of Python, what are the cases where that is ill-advised and they're actually better suited going with some of the native tools?
So the two cases that I would say, one is which is right now and one of which is likely long-term. If you want to write a game, Toga is the wrong choice for writing that game. Toga is a native widget toolkit. There is not a game on this planet that is written using a native widget toolkit. You need to have access to much lower level services to do that. That said, at some point in the future, I think it is inevitable that there will be at least a layer, whether it's Pygame or Pursued by Bear or something like that, that does play well with the briefcase layer. So it's like Beeware is a stack of tools. The whole Beeware stack from top to bottom is Toga on briefcase, on Rubicon, on Python in the browser. If you drop the Toga part at the top, you've still got a perfectly functioning stack, and you could potentially drop Pygame or Pursued by Bear or another game framework on top of that, and that could be a perfectly viable platform. Isn't there now, doesn't work on mobile, but it's something to look at. But right now, if you want to write a game, don't look at Toga, don't look at Beeware. The other is more a functional thing as of right now. If you have grand aspirations of building your next Instagram killing app and you need to build a prototype and you want to use Android as your original development environment, please do not use Beeware right now because it is version 0.3 for a reason. There are things that do not work. There are many things that do not work. If you are very enthusiastic and are willing to put on very sturdy gloves, you can certainly make a huge contribution. But if you are expecting to just drop in and have a productive development experience as good as if you just wrote a Kotlin app, you are not going to have that today. We certainly aspire to have that in the hopefully not too distant future, but right now we're not there.
Digging now into your plans for the near to medium term future, whether that's for Beeware, any of your own contributions to the PyScript ecosystem, the Python community and its ecosystem, or just overall world domination, what are some of the things that you're focused on right now?
Like I said before, is binary packaging on mobile, getting things working on M1, binary packaging on mobile, feature completeness to at least a version 1 level on Toga is kind of where the bulk of the focus will be, probably for the rest of this year. Yeah, that's sort of the immediate goals. Longer term, it's bigger, better, faster, more, and smoothing out more and more edges, finding out all of the more obscure ways that Android's toolchain breaks on Windows machines that don't have this extension or have Chinese language extensions turned on. The myriad of ways that things break because of the unique snowflakes that is each individual developer's machine, which is just a constant process of squashing bugs and finding out how things can break and how they break and what errors they tell you that in no way indicate what has gone wrong.
Are there any other aspects of your work on Beeware, your work with Anaconda, PyScript, Python writ large, Black Swans that we didn't discuss yet that you'd like to cover before we close out the show?
The only one that I point out, I did mention before, but Anaconda is hiring, very much hiring, both in the open source group, on the Beeware group specifically. I am currently looking for my offsider. Probably by the time this interview comes out, you won't have much time left to get in an application. But if you are keen, we are looking for people who are, if you've got mobile skills, if you've got any skills developing applications, or you've got experience just wielding gaffer tape and low-level kernel debug logs, maybe be your thing. But more generally, like Anaconda is hiring, and we are looking for people of all levels of skill to help through the entire company, both in the open source group and in the rest of the Anaconda product line.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this time around, I'm going to choose the Joby GorillaPod. So it's a little fairly portable tripod for your camera. It's very flexible, so you can, bend the legs so that you can, get a level shot on uneven surfaces or wrap it around a branch or whatever. So that if you're out hiking with your little point and shoot camera, it makes it a little more convenient to get some of those shots. So with that, I'll pass it to you, Russell. Do you have any picks this week?
One is a kind of obvious one that I will say, well, even if you have no intentions of developing with it, it is worth looking at PyScript to sort of see how much you can do with how little and just sort of think about where it could go. Like, it is a remarkably compelling demo in and of itself that is well worth playing around with. That's a bit of a gimme. The other one I say that I've recommended this to a bunch of people recently, and I don't think any of them have been disappointed yet. It is a TV show called The Great, subtitled An Occasionally True History of Catherine the Great. Recently wrapped its second season. I think there's a third one coming. It is a period drama, but not like any period drama you've ever seen. It is very weird. It is explicit. It is a little explicit, but not in a particularly, like, in a way that is historically at least vaguely accurate, although the actual history of Catherine the Great bears very little resemblance to the actual history. It is hilarious in all sorts of ways, and I've thoroughly enjoyed, absolutely binge-watched 2 seasons of it, so I heartily endorse it. If you don't like the first episode, you won't like the rest of it. If you do like the first episode, it only gets crazier from there.
All right. Well, thank you very much for taking the time today to join me and share some of your recent efforts and recent news and future trajectories. So it's always great catching up with you, and hope you enjoy the rest of your day.
Not much of it left for where I am in the world, but absolutely, and likewise to yourself.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.